Here are the answers for the section 13-6, day 2 homework assignment. We're going to start with some word problems. Number 2. If there are no intermarriages, how many ancestors have you had in the 10 generations preceding you? Let's model that out with a sequence. In the first generation that preceded you, that is your parents, that's 2 people. Then each of your parents would have had 2 parents. So then in that preceding generation to your parents, you have 4 ancestors. Those are your 4 grandparents. Now each of those 4 grandparents would have had 2 parents. So in the generation right before your grandparents, you have 8 ancestors, and so on. So what we have here is a geometric series where the value of r is 2. Now it says, how many ancestors have we had in the 10 generations preceding you? The very first number we wrote down, our parents, was that first generation right before us. And then this one here, our grandparents, was that second generation. So 10 generations would take us to the 10th term. We want to find the sum of 10 terms. So let's use our formula. S sub n equals a minus a times r to the n divided by 1 minus r. And we're finding the sum of 10 terms. The letter a is 2, the letter r is 2, and n is 10. And then in the denominator, 1 minus the 2. Then evaluate this. The result is 2,046 ancestors. Next, number 3. A man sends out 2 letters on Saturday with instructions to the recipients to write letters to 2 friends by the following Saturday, asking them to do likewise. If there are no duplications and no one breaks the chain, how many letters are sent in the first 8 Saturdays? Well, on the very first Saturday, how many letters are sent? The 2 letters sent by the man. Now on the second Saturday, how many letters are sent? Each of those 2 people that receive the letters will send to 2 more people, so 4 letters will be sent on that day. On the third Saturday, how many letters are sent? Each of those 4 people that receive letters will send to 2 people, creating 8 letters, and so on. The directions say how many are sent in the first 8 Saturdays, so that's going to take us out to the 8th term in the sequence. We want to sum this, so what kind of sequence is it? It's geometric, and the value of r is a 2. So let's use the formula we did last time. The sum of n terms equals a minus a times r to the n divided by 1 minus r. We want to find the sum of 8 terms. And for a, fill in 2. And for r, fill in 2. And then down here, 1 minus 2. This answer is 510. Next, number 6. A side of an equilateral triangle is 12 inches. The midpoints are joined to form an inscribed equilateral triangle, and the process is continued. Find the sum of the perimeters of the first 5 equilateral triangles. So we're told that we start with an equilateral triangle. We might sketch that. And each side is 12. The perimeter of that first triangle is 36. Then the midpoints are located. And an equilateral triangle is drawn in there. Well, each side of that triangle seems to be half as long as the 12. So those sides are 6. And the perimeter of that triangle is 18. Then the midpoints are located. And a triangle is drawn inside there. Well, how long are the sides of that blue triangle? There, 3. And so the perimeter of the blue triangle is 9. Now the directions say to find the sum for the first 5 equilateral triangles. What's the pattern? It looks like from term to term it's multiplying by a half, or another way to think of it, dividing by 2. So half of 9 is 4.5, and half of 4.5 is 2.25. To find the sum, we just need to add up those numbers. We could use a formula, but because there are only 5 numbers, it's pretty fast to add those up. And the result is 69.75 inches. Next, number 7. If the half-life of the uranium-230 isotope is 20.8 days, how much of a given amount of the isotope will be left after 104 days? This question doesn't tell us how much uranium-230 there is to begin with, but just to help us visualize the situation, let's choose a convenient amount. Let's say that there were 100 grams of uranium-230 to start with. The 230 is part of the name. It's called uranium-230. Now, in 20.8 days, there will be half left. That's what half-life means. That within that amount of time, 20.8 days, half of the uranium is converted to radioactive energy, and only half of the uranium is left as actual matter. So there'll be 50 grams left after 20.8 days. 20.8 days later, there will be half of the 50 grams left. So there will be 25 grams left after 41.6 days have gone by. In another 20.8 days, there'll be half of the 25 grams, which is 12.5 grams. And from the start, 62.4 days will have gone by. 20.8 days after that, there will be half of the 12.5, which is 6.25 grams. And in total, 83.2 days have gone by. 20.8 days after that, there will be half of the 6.25, which is 3.125. And in total, 104 days will have gone by. The question says, how much of a given amount of isotope will be left after 104 days? Well, there are 3.125 grams left if it started with 100 grams. What fractional amount of the original is that? So let's go 3.125 divided by 100 to see what that makes. As a decimal, that's 0.03125, but we can convert that to a common fraction. Using the fraction conversion key on the calculator, that's 1/32. So after 1, 2, 3, 4, 5 half-life periods go by, there will be 1/32 of the uranium left. A faster way of doing this problem would be to say that the common ratio R is 1/2. You're timesing by 1/2 each time, and you're doing that 5 times. That makes 1/32. That would have got us the answer really quickly. Now number 8, a certain lathe. A lathe is a piece of equipment in a wood shop that turns a piece of wood, allowing you to make it round. The lathe makes a total of 211 revolutions in the first 5 seconds after the motor is turned off. So the lathe is spinning the piece of wood, you turn the motor off, and in the first 5 seconds it continues to spin 211 revolutions. In any 1 second, its speed is 2/3 of its speed during the preceding second, and that's because it is slowing down. What was its speed in revolutions per second at the time the motor was turned off? So the speed at the time the motor was turned off is the first number of a sequence, where every second that goes by, the speed is 2/3 of the previous one. Well, we don't know the first number. Let's call it A. So the next speed is 2/3 of A. And the next one after that is 2/3 of 2/3 of A. And so on. If this one right here represents the original speed when you first turn the motor off, then 5 seconds later would actually take us to the 6th term. We're told that the total is 211. So we have a geometric series, and we know the sum is 211. Let's use our formula. S sub n equals a minus a times r to the n divided by 1 minus r. And for S sub n, fill in the 211. We don't know the value of a. We do know that r is 2/3, and that n is 6. And then 1 minus 2/3. Now let's do some algebra on this. We have 211 is equal to a minus a times 2 to the 6th power is 64, and 3 to the 6th power is 729. This is all over 1/3. Now we can multiply both sides by 1/3 to remove that denominator. That makes 70 and 1/3. Next, because the letter A appears in both of these terms, we can factor it. So we have 70 and 1/3 is equal to A times 1 minus 64 over 729. That makes 70 and 1/3 is equal to A times 665 over 729. To get the letter A alone, let's multiply both sides by the reciprocal of that fraction. So A is equal to 77.065 and so on as a decimal. And that's being measured in revolutions per second, or RPS. Now for the review assignment, page 497. For number 3, the directions are write the first 4 terms of an arithmetic progression. And we're given the first term is 2. We're given the value of d. So to go from term to term, you need to minus 1.3. 2 minus 1.3 is 0.7. And then 0.7 minus 1.3 makes negative 0.6. Negative 0.6 minus 1.3 makes negative 1.9. There are the first 4 terms. Next, number 9, we want to find the 21st term of an arithmetic progression where we know A and we know D. We have a formula for that. A sub n equals A plus n minus 1 times D. And we want to find A sub 21. So A is negative 2, n is 21, and D is 4. Then evaluate that answer. 20 times 4 is 80, negative 2 plus 80 is 78. Now page 499. This was the section about finding arithmetic means. To do that, we need to find the value of D. We know A, and we know the 1, 2, 3, 4, 5, 6, 7, 8th term. We know A sub 8. So let's use our general term formula again. And for A sub n, put in the 12, which is the A sub 8. That means that n is 8. Now add 2 to both sides and divide by 7. So 2 is equal to D. That's what you add each time to get the next term in the list. So negative 2 plus 2 is 0, then 2, 4, 6, 8, 10. Now page 503. This is where we learned how to sum up an arithmetic series when it was given to us in sigma notation. To find the sum of an arithmetic series, we have a formula. It's S sub n equals n divided by 2 times 2a plus n minus 1 times d. We need to know what a is, the first term. So to find the first term, fill in 1. 4 times 1 is 4, and 4 minus 2 is 2. The very first term is a 2. In our formula for the letter A, you can fill in 2. Now we need to know what D is. So D is the difference from that term to the next term. Well, what is the next term? Let's fill in a 2 for K. 4 times 2 is 8. 8 minus 2 makes 6. The value of A was 2, and the value of A sub 2 is 6. So that's a difference of 4. And notice right here that you see a 4. So the value of D is 4. Then evaluate this answer. 10 minus 1 is 9. 9 times 4 is 36. 4 plus 36 is 40. And 5 times 40 is 200. Now number 11. Find the sum of 12 terms when given this information. One of the things we're given is the last term, or the 12th term. And we do have a sum formula that involves knowing the last term. But that formula also requires that you know the first term. So the first thing we need to do is find the value of A. So let's use our general term formula again. In place of A sub n, fill in negative 32. We don't know what A is. N is 12. And D is negative 4. Now solve this for A. We have negative 32 is equal to A plus negative 44. Now add 44 to both sides, we get 12 equals A. Now we can use our sum formula. It's n divided by 2 times A plus L. So if we want to sum 12 terms, put 12 for n. For A, we now know that's 12. And for L, we know it's negative 32. 12 plus negative 32 is negative 20. And 6 times negative 20 is negative 120. Now number 15. Write out the first 3 terms given this information. Well, we're told the first one's 3, so notice I already wrote that in the answer. If we want to get the other terms, we need to know what D is, so that we can add that to our first term. What we have to work with is the sum, and we know A and L. So let's use the sum formula that had A and L in it. It looks like this. So for S of n, fill in 100. We don't know what n is. For A, fill in 3. For L, fill in 17. Now we can solve for n. Times by 2 on both sides. 20 times 10 is 200, so n is equal to 10. Now that we know the answer for n, we can use the general term formula to get the answer for D. So A sub n equals A plus n minus 1 times D. We now, for A sub n, can use A sub 10, which is the same thing as the last term, 17. So for A sub 10, we're actually going to use 17. A is 3. N is 10. We don't know D. Now solve for D. 17 minus 3 is 14 equals 9D. And divide by 9 on both sides. As a mixed number, this is 1 and 5/9. That's what you add to go from term to term. So this one is 4 and 5/9. And the next one is going to be 6 and 1/9.